This is a series of videos summarizing how I've come to think about binary data and mathematical operations. Each video will be supplemented with a JavaScript API and web demo. See the description for those links and additional references. I started this journey several years ago when I was tasked with implementing a Vandermonde-Reed-Solomon ECC pattern. I succeeded in implementing the ECC system by study of the subject literature, but was left with many questions about why it worked. My investigation led me here, the number triangle. I've since learned to use it as my primary mathematical perspective. It gracefully integrates and simplifies more advanced concepts, and provides a seamless way of relating data and mathematics. Here is an interesting variation on the number triangle that has useful properties. More on this later. Allow me to summarize why I think it is important. It's an intuitive and simple mathematical tool for data, intended to be used by programmers. It allows us the benefit of thinking in terms of data and not functions or equations, and also knowing how that data relates to those functions and equations. It is a literal notation instead of an abstract or symbolic notation. It becomes very useful for designing algorithms and analyzing data. It allows us to write programs without complicated libraries. This is useful for high performance, low power, and embedded applications. As a fundamental principle, there are many different subjects we can view from this perspective. We'll explore each of these later in the series. First of all, what do I mean by data? Data is a set of numbers. Conventionally, when dealing with data in programming, it has a unit and a block size. A unit, for example, can be a byte, a set of 8 bits, which allows for numbers from -128 to 127. A block is a set of these units which allows computational work to be partitioned, facilitating resource management and task parallelization. A block might be 4096 bytes for an algorithm with high resource requirements, or 1,000,000 bytes for a simple algorithm. This ties us back to the most common data abstraction, a file. A file can be represented as a set of blocks. Okay, let me define what I mean by number triangle. A number triangle is constructed from units listed vertically, columns representing groups of data, the first column being the original data. Subsequent columns are constructed of the differences between the units of the previous. Here are some observations about the number triangle. With a column of n length, a function of degree n-1 is required to perfectly represent the original data. Observation 2. The presence of a 0 indicates a pattern. The 0 in the last column here indicates that this is a binomial and not a quadratic function. Now let's convert data to a function. We can think of each iteration of a function as the sum of powers multiplied by the coefficients. This introduces us to what I found to be a quite useful principle. I like to call it the power pyramid. Notice that this comes intuitively as a consequence of exploring the number triangle. We perform the same derivative step on each iteration of the function instead of summing the parts. This illustrates to us something more about the structure of functions. See how each level of the power pyramid cancels out the previous coefficients. This allows us to construct a function directly from data. To convert a data column to a function, we need this power table and its derivatives. ax squared plus bx plus c, such that f1 equals w, f2 equals y, and f3 equals z. 2a equals z minus 2y plus w. 3a plus b equals y minus w. A plus B plus C equals W. Let's look at an example of this. I've highlighted the matching columns in the power pyramid and the number triangle. A is 1, B is -1, C is -1. The function that recreates our data column is x squared minus x minus 1. Some final observations. Multivariable functions can be constructed by repeating the conversion process recursively, forming a fractal number triangle of sorts. We can mix functions of different degrees in this recursive process. Using this process, we can define relationships between functions and classify them into groups. Web Demo and JavaScript API available at math.d8data.io.